This question is from GATE 2021 Mechanical Engineering Paper Set 1, question number 54. A machine part in the form of cantilever beam is subjected to fluctuating load as shown in the figure. The load varies from 800 Newton to 1600 Newton. The modified endurance, yield and ultimate strengths of the material are 200 megapascal, 500 megapascal and 600 megapascal respectively. The factor of safety of the beam using modified Goodman criteria is dash, rounded off to 1 decimal place. Let's find out. So as per Goodman's criteria, we have the mean stress sigma m by the ultimate strength SU plus the amplitude of stress sigma A by the endurance strength SE should be less than or equal to 1 by n. So this is the safety condition or the limiting condition where n is the factor of safety. So knowing these values sigma m, sigma A, SU and SE, we can find out the factor of safety. We are being given the values here. Endurance strength is given 200 megapascal. Ultimate strength is given 600 megapascal. And yield strength is also given, but because we don't need it, we won't write it. Our job is to find out sigma m and sigma A. So the stress values are not directly given, but the fluctuating load is being given here. And therefore, we will have to find out the stress value. So this is the cantilever beam shown with a point load. Point load varies from 800 to 1600 Newton. Just using vertical equilibrium, we know that vertical reaction at the support will be, for 800 Newton, it will be 800 Newton. And for 1600 Newton, it will be 1600 Newton itself. Because the net vertical force in the system should be 0. We will also have a resisting moment here. And because this moment is clockwise in direction, the resisting moment will be anti-clockwise. And this resisting moment will be nothing but 800 into the span, which is given to be 100 millimeters. So we have 800 into 100 and 1600 into 100. The unit will be Newton millimeter. So we have the values of moments here. We can find out the maximum and minimum stress value. Using pure bending formula, we have m by I equal to sigma by y equal to E by R. Finding out the stress, we take the first two terms, first two ratios. So sigma will be equal to my by I. Value of y and I remains the same because cross section is the same here. So sigma max will be moment value being 1600 into 100, which is nothing but 16 into 10 to the power 4 Newton millimeter, into y will be 20 millimeter is the depth of the beam. So the extreme fiber from neutral axis is 10 millimeters away, divided by I can be calculated from the given cross section. So we have width of the beam is 12 millimeter into depth cube. So 20 cube divided by 12, BD cube by 12. It's a rectangular cross section. So we get the maximum stress value as 200 megapascal. You can also calculate the minimum stress value similarly, and minimum stress value here turns out to be 100 megapascal. We have maximum and minimum stress values. Now we can simply calculate the mean stress value and the amplitude of stress. So mean stress value will be just average of 200 plus 100 by 2, which is 150 megapascal. And amplitude of stress sigma A will be 200 minus 100 by 2, which is 100 by 2, 50 megapascal. Putting these values here in the Goodman criteria, we will have the factor of safety as factor of safety n equal to 1 upon 150 by 600 plus 50 upon 200. This turns out to be 2. So they have already mentioned that you have to use the modified Goodman criteria only, and that gives the factor of safety answer as 2. If it wasn't mentioned, then you can use the other methods and see which gives the maximum value of factor of safety. That will be our answer. In this case, 2 is the answer. Let's go back and fill in this answer. The answer is an integer, which is 2. To learn more about these topics and fatigue failures, you can refer to the NPTEL video, lecture 26, part 2, fatigue failure of materials, effect of mean stress. This video is from the course Basics of Materials Engineering. The course is taught by Professor Ratnakumar Annavatulla. He is from Department of Mechanical Engineering of IIT Madras. I hope this solution helps you clear your doubt. Thank you.